Video lesson 2.4, angles in a triangle. So this video is going to talk about specifically the relationships of the angles within the triangle, whether they're physically inside of it or adjacent to it on the outside, but having to deal with the actual triangle relationship itself. So hopefully the first property we already know. This should be a review, but if not, here's an opportunity to learn it now. No matter what type of triangle we have, the sum of those three angles within the triangle will always be equal to 180 degrees. Always. Okay. So again, once I identify that I have a triangle, so if I look here, I've got this triangle here, right? I've got this triangle here. All right, I've got this triangle over here. Again, I've got various triangles going on in this particular question. No matter which one I'm referring to, the blue, the pink, the orange, they all have a total sum of 180 degrees. All right, by definition of a triangle, that must be true. Right? It doesn't matter if it's a regular triangle that's, that has no equal sides, or if it's like called a scalene triangle, or a isosceles triangle with two equal sides, or an equilateral triangle with all three sides. It doesn't matter. The sum is always going to be 180. The individual angles will change, but the total sum is always 180. So once we know that, that allows us to kind of figure out the answers to missing pieces. So in this first one, we've got two missing angles, angle A and angle B. Let's start with angle A in this case. And it doesn't really matter, but I already have two out of the three angles in this one, so it makes my life a little bit easier in order to find that one. All I got to do is just simply add all three of them together, set it equal to 180, and we're good to go. So for part A, we're going to say A plus 69 plus 58 all has to equal 180. Right? And now I'm just regular solve equations once I know. So knowing that fact allows me to set this up, and then I can just solve away. So this first section I'm just going to combine like terms. So A is going to be, 127 is equal to 180. If I subtract the 127 from both sides, these will cancel. A will be, that's 53 degrees for A. And we're good. All right, so I can plug that in. So now I know this is here. So again, I recommend plugging it into your actual problems, into your diagram, because that allows you to maybe help you find something else for another part. So for angle B, we've got multiple options. All right, we could focus on this little triangle here, right, which is the orange triangle that I highlighted here in orange, right, which is fine, and I can do this, right? I can find these. I would need to find these other two angles before I could find B, but I can do that, right? I could figure out what this is here, this angle right here, because it's supplementary to the angle 69. I could find this one here because it is supplementary to 93 and 58 altogether. Perfectly fine. I could do that, right? Or I just take that away for a second. Or I could focus on the big triangle, this big blue triangle, right? I could look at it from this perspective. And again, that's the difference. It's all about the perspective that you're looking at it from. There's no right or wrong here. One might be slightly easier than the other or faster, but that's really it. There's not like you have to do one versus the other. But if I look at the big triangle, we just found A, which is one of the angles in that triangle. We're looking for B, right? And then this big angle here would be the third angle. So all I'd have to do prior to solving for B is to find this little portion here. So in comparison to the two versions here, whether I look for B by solving the big blue triangle or look for B solving it with the orange triangle, technically the blue triangle has one less thing, because all I got to do before I can even answer the question is just find this one particular little piece. All right. So if I look at this piece here, right, let's just call it X for a second, right? I could say, well, 58 plus X plus 93 all has to equal 180 because these is one straight line. And again, I'll highlight that here. All of this forms that straight line, so they are supplementary. So if I do that, in this one here, let's see if I combine like terms, right? 58 and 93 here. What's that going to get me? That's 140. No, that's not 140. So 58 and 93, that's what, 151. And we take that away from 180. And that's going to give me a value of x of 29. So now I know this is 29. I'm just going to write that in here so you can see it. So now I can say that this whole piece, and this whole third angle here is 29 and 58. And what does that give me? That's 87. So this whole thing is 87. I'm just going to do that off to the side here. I'm going to do it out here as 87, just so it's easier because my diagram's getting a little busy here. But for B, we now can say that B plus the 53 I found earlier, plus this third angle, which is, again, is 29 and 58 together. That got me the 87 that I wrote down here, which was in yellow. That was hard to see. And that's 180 degrees total. So now 87 plus the 53, that's 140. Bring everything else down, subtract the 140 from both sides. I now have B as 40 degrees. And I'm done. All right, if we move along, right, and look at other triangles, we see here that one other fact that is very important, that is base angles of an isosceles triangle are equal in measure. So visually, we have two little tally marks, we call them, are showing me that these two sides, so I'm just going to highlight these sides in yellow here. So this side and this side here are the yellow sides. Those are equal in measure. And by definition, right, if I have two equal sides, the angles across from them, which we refer to as the base angles, that's what we were saying up here, the base angles, they are also going to be equal then. So if this is 68, automatically we know that this is 68 if it is in fact a isosceles triangle, which they told me it was. So once I have that, now I have this triangle here, right, which we can find x with. Right, so now I can say that x plus the two other angles within the triangle, 68 and 68, must all add up to 180. So if I combine like terms, that's 68 and 68 is 136. So now I can subtract 136 from both sides, and that gives me x to be 44 degrees. So now I have this piece. So if I'm looking for y here, notice y is outside of the triangle, right? However, this angle is just an extension of one of the sides. So all they've done is take this other side and they just extended it, and it created this angle here, right? So together, x and y form a straight line here. So that means that x plus y is equal to 180 degrees. These are supplementary angles. So we just found x, right? We know that this is 44. We're looking for y, so I'm going to keep that as y. All equals 180. So if I subtract the 44 from both sides, I get y is equal to 136 degrees. And now that's what we have for this one. Another key thing to note is that if all of the sides and or all of the angles are equal, then we have an equilateral triangle. Helps if I spell that correctly. All right, an equilateral triangle. And all three of those angles will always equal 60 degrees. That's an important fact. So again, visually, we can look at it. It would tell us with the tally marks that we've got three equal sides, or they could write in here and that all three of these angles would always be 60 degrees, because again, if it's three equal sides, it means it has three equal angles, and 180 divided by 3 is 60. So each one of those has to be 60 degrees. important things. So these are two important triangle types to know. Isosceles meaning two. Think eyes, like a pair of eyes. You have two eyes. Equilateral, everything is equal, all three of them in there. All right, next one here is we've got a situation here that we have a right triangle, right, which is another type of triangle that we could have. The sum of the two acute angles is always 90 degrees. What does that mean? So if you look at this, right, we've got a right angle here that says outside. That means that the other side of it, aka this one here, is also 90 because that would form a straight line. So if I got perpendicular on this side or right angle, I also have it on the other side. And the two acute are these two angles here. These two. They're always going to add up to 90 degrees because if this one is 90, right? If this angle right here is 90 degrees, right? 180 minus 90 is 90, which means these other two have to also add up to 90 degrees. All right? That makes these complementary angles. All right, so these two other angles are always going to be complementary angles. So I don't have to make an entire sentence. I mean, you could just go by the normal concept, and let's call this x for the argument. We can say x plus 25 plus 90 all equals 180, just like we did on all the other questions, because again, all three of these angles add up to 180 degrees to form the triangle. But we can shortcut this, right? So we can say, or I don't have to worry about all three of them because we know this is 90. That means the other two have to add to 90. So we can shortcut this sentence and just simply say that x plus 25, aka the other two angles that are not the right angle, have to add up to 90 degrees. And it just makes our math a little bit faster and easier to work with, right? Again, both of them will work. It's not super, like one's super faster than the other. It's just one makes it a little bit easier than the other one. So it's not, just a preference at that point. But I think it's worth noting because, again, anytime I can save in the process would make things easier. So making this third angle 65 degrees, or aka what we called x. All right, last but not least, let's leave you here with this last thought and last type of situation that deals with triangles. And that is that if we have an exterior angle, like in this case, we have angle A is my exterior angle. It's outside of the triangle, but it's formed by extending one of the sides of the triangle. So in this case, we just extended this side of the triangle outside of the, past the angle or past the vertex point, which is right here, and it formed this angle A out there, okay? That angle will always be equal to the sum of these two remote interior, right? We call these remote interior angles, meaning not the angle next to it, right? That would be its supplement, right? The other two, right? So by definition, right, this says that A is equal to the sum of 56 plus 45, right? So A equals, what is that, 45 plus 56, that's going to give me 101, right? So I can quickly, by knowing this fact, get my answer. This is known as the exterior angle theorem, all right? And I can get there fast. Now, the one good thing is if you didn't know that or you forgot it, you can still get there. Because again, we could figure out this angle right here, right? This other third angle, 56 plus 45 plus this missing angle, I'll call it x here, would end up giving me the three angles in a triangle, and we know they have to add up to 180. So it would be x plus 56 plus 45 all equals 180. We can combine like terms, right? X plus 101 is equal to 180. Subtract that from both sides. We now know that x is equal to, that would be 79. Right? If I know that this is 79, then you could say that A plus 79 has to equal 180 because those two angles are supplementary. And if I subtract the 79 from both sides, I get A to equal 101. So I can get there without knowing this theorem, but look how much extra work I did, right? Knowing the theorem got me this answer just simply by just literally adding two numbers together. You couldn't get any simpler than that, really. Here I got to do a lot more work on over here, right? But again, it's fine. It gets you the answer. So there is an alternative method here. But we really do like this exterior angle theorem, right? It is very beneficial to know it. It will make your life a lot easier and faster to be able to answer a lot of these questions. So with that being said, let's take an end to this video. Again, feel free to pause the video, go back, look over anything, and try any of it again on your own, and ask questions in class.